Okay, so I would like to thank everybody for coming in and joining the meeting. It looks like looks like it's settled down. All the attendee numbers are kind of stagnant now. So everybody really pops in the last, I think everybody gets reminders on their phones and email and everything about right exactly at 8 o'clock. So everybody just kind of jumps in right at the exact same time. So yeah, we'll give a presentation on iMachining for NX 2021 SP5, and then at the end, if anybody has any questions, we can answer them. So there's a chat in the GoToMeeting panel on your right hand side, and if you have any questions, just throw them in there, and then I'll answer them at the end. So let's get started. So first, my name is Anthony Calderone. I am the Chief Technical Officer at SolidCAM, and we're going to be going over iMachining for NX 2021. So we have a new version now. This is iMachining for NX 2021. For any of our existing customers for iMachining for NX, you will know that the previous versions were called like NX 1.0, NX 2.0, and now we are renaming our system to work with the year version because now we are fully synchronized with our SolidCAM and InventorCAM products. And this is actually a huge leap forward for our iMachining for NX product. And basically what, I won't get into all the technical details, but basically when we did our integration into NX in the beginning, it wasn't the same as what our integrations are with SolidWorks and Inventor. So since we were only placing iMachining 2D and 3D into NX, we had to do a different type of integration. And when we did this, it kind of made we kind of copied all of our code that had to do with iMachining. And what this meant was anytime a new feature came out for iMachining, we basically had to add it also to SolidCAM and InventorCAM. And then we also had to do a certain amount of work, not duplicate work, but almost the same amount of work to get it into the NX version. So what this meant was that through, over the past 4 years or so, we couldn't add all the things that we added into SolidCAM into our iMachining for NX. About a year and a half ago, we decided to make the integration similar. And from everything we learned from our first time, and now we share the same code base with our other products. So what this means is that basically everything that we add to SolidCAM for iMachining, we get automatically in our iMachining for NX product without having to do nothing more than really just add the UI elements, and we get it. So basically this means all of our customers are on the same versions, the same options, and basically what I'm going to go over today is what you'll see now that we have the same version. So I'm going to go over like our new features, and basically what this kind of, from a high level point, you could almost say that all of the features that we've added since SolidCAM 2016 are in this new version. Of course, as I said, through the years, we've been adding individual features as we could to the NX product. So it's not every option, but more or less, there's every option we've added since 2016 now is in this new iMachining for NX version. So it's really a huge feature update for iMachining for NX. So we have like our feature recognition code, we have finishing options, we have pre-drilling, floor fillets, new database for iMachining, downloadable toolpath engines. So all these things are now new. The flagship feature that we've added is our geometry definition modes. And this is, I think, really the biggest difference that you're going to notice when you open up iMachining for NX 2021 and compared to the previous version. For the most part, everything else in the UI is going to look exactly the same because it's kind of the same options, but the geometry definition modes are completely new. So what is this? We have something called geometry feature recognition or machinable features. So in one sense, for anybody that is using NX and is familiar with the NX IPW floor wall machining, where like when you pick a floor, it can extend it to the pot to like the stock, and it kind of auto detects walls. You can say this is something kind of similar. It's of the same like style that basically what we're trying to do, and I think the same thing there with the floor wall machining is that you want to use the full solid geometry of the model, stock, target, fixture. And what you want to be able to do is make the geometry easy. You kind of pick some faces, you say, hey, I want to machine this. And then you use the software with all of the solid model data to try and find what is the feature that you're trying to machine. Now with iMachining, we have basically 4 different geometry modes that we support. Feature recognition by faces, feature recognition by chains, outside feature recognition, and then our chains without feature recognition. So chains without feature recognition is basically what everybody's used in the past. You pick a chain, you mark open edges, open chains, closed chains if they're closed pockets or semi-open pockets. So that is the old standard method, and that exists in there. The other big thing that we've added is finishing. So we've always had finishing in iMachining, but now, since the previous time, we now have more automated control over this machining process. So we're able to do more finishing for walls and floors in the same iMachining operation or in preceding operations. So because generally when we're machining, let's say and we're talking about 2.5D here, when we're machining the prismatic feature, pockets, walls, floors, things like that, the same geometry that you pick to rough is generally the same geometry you're going to do finishing on. If you have like a soft material like aluminum, you might be even finishing with the exact same tool. So you can do the finishing directly in the same operation, and we're offering all sorts of different options to machine the floors with the different strategy. You have different speeds and feeds, RPMs for the finishing. One of the major enhancements that we added was floor finishing with a contour style. So basically the existing way we always had was finishing the floor with an iMachining style toolpath. So basically this gave you exactly the same iMachining pattern. This works really awesome with hard material because it's controlling the engagement angle, it doesn't beat up the tool. As you get into softer materials though, one of the requests was, hey, listen, we're only machining just 10th thou off the floor, or 40 microns or something like that off of the floor. And we want to be able to do it either in a big step over because it's faster, or people want that exact look on the part. So as we know, when it comes to the finishing and you look at a machined part, the final pattern that you see on the floor, the aesthetics can be important to what your part is, so not that this contour style versus an iMachining style really is changing the quality of the floor, but it does change the visual aesthetics of what it looks like. And as we know, looking at a lot of parts, especially parts that are going to be used on something visual, motorcycle parts, anything that you see the part, a lot of people, they don't want to see this spiral looking tool path. In the end, it's an awesome cutting tool path, but it looks, let's say, maybe not the most aesthetic tool path. And people like to see kind of like this contour style strategy that offsets from the wall, and it just has that neat kind of machining look. You look at it and everybody knows, like, oh, that's a machined part. We've also added cutting directions. So we now support climb and conventional cutting. This also, this is something that's used for, if you have, some tools are meant to cut conventional. So, some tools where you're cutting some materials where you actually do want to cut conventional. If you're mirroring toolpath, being able to have a conventional toolpath that gets mirrored now becomes climb cutting. And then we also have zigzag machining, which is basically if you have something like a really soft material and look, I'm the type of person who still believes climb cutting is 99% what you want to do, but definitely we have customers with, especially I'd say NX customers, really big parts, especially aerospace parts, where you're doing long cuts and big horizontals, big machines and aluminum using pretty big cutters. And obviously, if you're using a 3/4 inch end mill in aluminum, you can climb in conventional cut. So it's definitely, the tool is going to accept it, especially when it's not some really long tool. So being able to do zigzag machining in iMachining, it allows you to, the tool to cut one way instead of repositioning and coming back to the beginning of the pocket. It can just cut and do a zigzag tool path. And you can see here in the picture. So like if we, in the corners here, if you're doing always climb cutting, you always get a reposition to come back to the next cut. Here you can see if we're doing zigzag machining, after it does one cut, it just repositions and does the next cut. So you're basically getting, that zigzag machining. As I mentioned with the finishing, one of the most important things with finishing in the same operation is separate feeds and speeds. As we know, there is definitely a difference in RPM and feed rates, whether you're doing the roughing, whether you're helical entering, whether you're finishing the wall, and whether you're finishing the floor. So as you can see here in the operation, all of these things are filled out automatically by the technology wizard, but all of these options have an override checkbox, so you can type in your own feed rates and RPMs. Because in the end, it's, many people have their, you would know with this 1/2-inch tool, I like to do my finishing at 4,000 RPMs and 35 inches a minute for the floor or something like that. So you can, even though the wizard is filling out all of the feeds and speeds, you can override any of the RPMs and feed rates directly in the operation and switch to them. We've always had pre-drilling in the iMachining for NX product, but now a few years ago we did an enhancement to the pre-drilling where now we also know about the drill point or the tip of material that's left at the bottom of the pocket. So what this means is that, if we have a closed pocket here, when we use a pre-drill, unless you're using a drill with a flat bottom, which really I don't think you would consider a drill, like you have an end mill or something, you're going to end up in a situation where there is material, a tip down at the bottom. So what iMachining does is it knows the tip, it plunges down to the top of the tip, we helical enter out just that material that's left over from the tip, and then we continue machining. If we look down here at this pocket, if you're obviously machining something that's a through pocket and your drill is able to go all the way through, well then there's no tip to clean out. So this is a really important thing because in the end, helical entering is definitely one of the most challenging things for end mills. And I would say now with a lot of with the specialized tools that are coming from manufacturers for doing, radial engagement tool paths, a lot of these tools don't really have the ability to do center cutting. They're using big core diameters, things that are really nice for, for iMachining style tool paths. But one of the things you lack is the ability to do helical entering. Or there's just not a lot of cutting that you can do at the center. Like technically they support helical enter, but it doesn't do a lot of good cutting at the center. So, I mean, when in doubt, pre-drilling is one of the best things you can do, especially in a closed pocket. So being able to do pre-drilling is critically important. And the fact that we now do, we take care of the drill point, just whatever pre-drill you can throw in your part, just do it. I mean, even if you're just throwing in, a 1/8 diameter drill or whatever drill is in the part, I always say this: if there's a drill in in that tool carousel for the part you're machining, pre-drill your pocket just so there's some hole in the center. The difference between just having a 1/8 hole for where it plunges, it really makes a huge difference on the helical end mill when you're plunging. And of course, we also have pre-drill support in iMachining 3D, which we did not in the previous version of iMachining for NX. So now you can also do the same thing in 3D machining, which is, as I said, really awesome because pre-drilling really makes a huge difference. We also have a redesigned material database for iMachining, and this also includes groups, new options, and things like that. So here you can see, basically, we have a lot more granular control over the materials and the machines. And what you also have is groups. And what these groups allow you to do is, if you place your material into the proper group, it gives more accurate cutting force calculations. When we do ultimate tensile strength for the machine definition or for the material definition, while that's pretty accurate, the same tensile strength between two different materials can have a different cutting force. So we have these groups now, and you can place your material into these different groups. And this was something we did also with we did at a university with test cutting with a dynamometer, where we actually measured the cutting forces between different materials, and we grouped these things, and now we have more accurate cutting force calculations. We also have a minimum helical ramping radius, really good for something like aluminum. So now, in the past, we always limited the helical radius to 170%, so that way there was some room. Now you're able to define a helical radius that's different. We also support 3D positioning in iMachining 2D. So this is actually a very awesome thing. So for anybody that uses iMachining 3D, we know the tool is always staying down, right? So like once it starts cutting, iMachining 3D does this magical thing where it really is keeping the tool, if it needs down underneath the part, if it needs to go from one area of the model to the other area of the model, it just lifts up and up that it needs to. It repositions really quickly around the part, and we get our machining. So in 2D iMachining, we do that to a certain extent, but in 2D iMachining, we never knew the full model. We didn't know the stock, the full, the 3D version of the stock, the 3D version of the target. We only knew the boundary of the geometry that was sent. So now in iMachining 2D, with all the new feature recognition code, we now actually use the stock and the target and the fixture. So what you get is smart positioning or 3D positioning. I would say in iMachining 2D, this isn't as huge of a increase as it is for iMachining 3D, because in iMachining 3D, you're getting lots of little passes all over the place as you're trying to bring the model into its net finish with the scallop machining. But I mean, if we look at even just a simple like roughing and finishing toolpath. So here we have a toolpath which is roughing and finishing. You can tell it's finishing because it's also finishing the floor with the contour strategy, so you can kind of see the floor, the offset passes. As we know with iMachining finishing, we clean out the corners and do a finish pass. So here you can see there's, I don't know, 1, 2, 3, 4, 5, 6, there's like 6 or 7 repositions where the tool is returning to the clearance plane, wrapping over, wrapping back down. And when we look at 3D positioning turned on, now you can see the tool is able to have one entrance into it. And if you look, there's 0 retracts to the clearance plane with movements. All of the cutting is done while the tool is down in the pocket. It just moves up the safety distance or the in-pocket positioning that we use for iMachining, and all of that positioning is done down inside the pocket. As a machinist, would I say that this is going to have a faster cycle time? Maybe a little bit, because as we know, when the machine is rapiding, it machines in exact stop mode. So every time you wrap it, it does take time to go up and down. From my side, I like it more as a operator because, I always feel like every time the tool rapids up and then is rapiding over and rapiding down, it's like that, it's that position that when you're running the machine, especially in the setup, when you're first setting up the part and you're running through before you've actually, have a whole part running, this is where you're a little concerned. Every time the tool plunges down, you're like, okay, is the machine going to do everything it's supposed to? Is everything cleared out? So here with 3D positioning, the tool is just down in the pocket the entire time. I feel like from my side, it just feels like an easier thing on your stress level when you're running the machine, that, hey, the tool's staying down in the pocket, you can run it, and everything is good, so, but it's an option, it's something you can turn on and off. So that's kind of like the major features of what you get going from the previous version of iMachining for NX to the new version of iMachining for NX 2021. There is a what's new that actually goes over all the individual features, because there is so many more little features that have been added all over the place. I mean, 3D iMachining, you can limit the cutting to 1 ACP. We automatically in iMachining 3D, we automatically change the cutting angle on every depth of cut. So like when the tool is stepping up, we increase the engagement angle to have the same cutting forces and to have more efficiency. So if you look at the what's new for SolidCAM for iMachining 2021, it's the what's new is huge. I forget how many pages it is, but I'm sure it's 40 or 50 pages. So let's take a look at the previous slide. Let's go take a look at what it looks like in iMachining for NX. Now, when we switch over to NX, what the only difference I would say as an existing NX user that you're going, an existing iMachining for NX user, the big thing you're going to notice is there's now an iMachining for NX ribbon. So this gives us some new flexibility to be able to do additional things that we didn't have in the past. Like for instance, you can now set your iMachining material databases and do all this directly from the ribbon, where before it had to be done from inside of the user operation. You can also easily check what iMachining version you're using. You can get to your settings, and you can also quit the iMachining process. This is basically releasing of the license, because every time SolidCAM loads, it is loading in memory, and that license is being used. So when you're ready, if you want to give back, you can quit iMachining process. So that's pretty much the big thing you'll notice when looking at it. The rest of this is all going to be pretty much the same. So what we're going to do is we're going to insert a operation, and we're going to go to iMachining. We're going to start with iMachining 2D. We have our tool that we're going to use, workpiece, method. This is all standard stuff everybody should know. And we're going to go into the user parameters. So when we go into the user parameters, this dialog is going to look very, 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 very similar to what you had in the previous version. The main difference you're going to see is just this geometry tab up here is going to look a bit different, because now we have our geometry selection modes. So here's our feature recognition by chains, feature recognition by faces, outside, feature recognition, and chains without. So we want to use faces recognition, and we'll just kind of give a quick walkthrough about what happened. So I want to machine this face. So in the end, I want to think very simply and just say, hey, that's the face I want to machine. Hit OK. The our machinable feature recognition code analyzes this face and determines how can I machine that face with the stock, the target, and the fixturing. So let's take a look at what this actually does. So if we find, I think this bounding body, yeah. So this is the actual stock, so this bounding body 2. So if we see the stock, we have material basically, I don't know, I think it's like 5 millimeters or 1/4 inch, something on the outside of the part. So even though I picked this individual face, it automatically extended the pocket out to the stock. We also add these little these wall protectors that keeps the tool path from kind of rolling around. We automatically determine the highest point of the stock. So basically what you get in the feature recognition code is we find the 3D region with the levels extended to the stock. If there was a fixture in the way, it automatically protects against the fixture. If you have a holder, it automatically protects the holder against the stock, plus even also the fixture. So all of this stuff gets automatically built and protected, and it's pretty much as simple as picking a face. Everything else that we're going to see in here, you're going to see is pretty similar. So I mean, cut levels, this is pretty much the same. We have cutting parameters. This is the same as the previous version, except for the fact that we now have additional features in here. We go to the technology wizard. So in the technology wizard, we have our machining levels. We could take a look at our feed rates, engagement angles. So we're doing cutting angles, 44 degrees. We can see the RPM that's running. We have all of our modified cutting conditions. Everybody should know that the helical angle for the tool is also stored here, because since we're in NX, the helical angle of the tool is not a parameter of the tool in NX. So we define the helix angle here. And so yeah, as you can see, this is pretty much the same as what you see before. I will calculate this toolpath. Toolpath gets calculated. I will hide the machining boundary. Let's just verify this toolpath and see what we get. We'll do 3D dynamic, and we'll play. So here we can see the pocket is being progressively shaved away from the material. Once again, the beautiful thing here is we just picked a simple face. It was automatically extended out to the stock. Everything was kind of managed for us. We didn't have to worry about, hey, where do we need to start cutting from the top? It automatically found the region. It found, okay, well, in this area, this is the highest point of the stock, so I need to start machining from there. And basically, you get this automatically. Very, very simple. The whole thing with iMachining feature recognition geometry is that it's easy and it just works. So now let's say we want to, I'm just going to do one more toolpath, and I could copy and paste, but I'm just going to insert another one. So you can create operations from the ribbon, you can create operations from the tree, I think everybody's familiar with this. Now this time what I want to do is I want to machine this face here. So I'm going to use the same geometry faces recognition. We're going to pick on the face. We're going to pick this face. And this is a really awesome example to show how powerful this technology is. So if we look at this blue region, we can see what the feature recognition code did and how this got modified and extended and adapted to the stock and the target. So if we go back and look at our stock, we can kind of see what went on. So we want to machine this pocket, right? So we pick this face. Well, with that face, we have walls, but then it's just an open pocket. Like all the other edges and stuff are all machined out to like air. So in a traditional sense, somebody would, if you normally picked on this pocket, especially with this crazy geometry, you'd end up with just a toolpath that's really just machining this face. Well, what's that going to do? It's going to plunge on material everywhere. It's obviously not going to be good. So the feature recognition code automatically said, okay, this area is open. I need to extend this and find the region out here on this side. It did the same thing on the right. And you can also see here, because it's working with the in-process IPW in NX, it is automatically trimmed out to this section. So if we now just take this toolpath and calculate it, we get the calculated toolpath. Just looking at the wireframe real quick, we can see there's no extra toolpath here over in this area. We can see all the toolpath is starting from the outside of the stock. If we go to the verify, turn off the bounding box, hit play. Here we can see iMachining's patented channeling. So what this does is this channels along the walls. And what this is going to do is this is going to separate the geometry so that way we can machine this area and this area with a spiral toolpath. And in the end, the spiral toolpath is the best for the tool because it keeps the tool moving in the same direction. So here you see the spiral. So we're spiraling. This is the nicest, the less amount of lead in and lead outs, which is, the most difficult thing for the tool. And we can speed that up. And there we get our spiraling toolpath. So the feature recognition code is really, 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 really awesome. I mean, it's not the, it's not the end all be all of geometry selection. So for sure, you will be sometimes creating a sketch and, controlling the toolpath with a sketch in NX. We're picking it off the model. But being able to just pick faces and have all the stock and extensions handled, it really does, limit. It really does minimize the time that you spend creating the operation. It really allows you to focus on, picking the machining the way you want, analyzing the cutting, and doing what you need to do, not doing it and not trying to figure out all the different geometries you need to do. Okay, let's now switch over to close all parts. Yeah, we can save it. Yes. Now let's look at iMachining 3D. So in iMachining 3D, let's insert an operation, iMachining 3D. In iMachining 3D, you're not going to see too much of a difference between, at least nothing major when you look at the operation in comparison to the previous version of NX. Because iMachining 3D, it already used the stock and target and fixture from the beginning, so all that stuff has always been in there. So the biggest thing, let me just set I'll set the lower level to machine to there. We'll start machining at Z0. In the cutting parameters, you are going to notice new features. So like I said, we have some max cutting angles that, because we dynamically adjust the cutting angle as the depth of cut decreases when it's doing step up. We also have the ability to limit the depth of cut to 1 ACPs. As I said, if you go through the what's new documentation, it goes over all these new things. But in the end, you're not going to see too much difference things in here because it basically is kind of the same. We do have fit arcs control. You can try to you can play around with the tolerancing as if you want shorter G code. That's at the expense of a less accurate toolpath. But we have had requests with customers that have older machines that, especially with aluminum and stuff like that, the cutting angle doesn't have to be so perfect. The tool's definitely much more forgiving cutting aluminum, but people have asked for being able to get shorter G code. So we now added the ability to fit arcs to the toolpath, and you can change the tolerancing. And we have it listed under beta because it's kind of use at your own risk, because as I said, it does change the cutting characteristics, because if you fit arcs to the toolpath, it's not cutting the, if you tell iMachining to use a 30-degree cutting angle, if you fit arcs and use a big tolerance, you're not going to be cutting with 30 degrees anymore, because the toolpath is getting, modified by filtering, by applying arcs. And yeah, Technology Wizard, we have all this in here, same kind of stuff. Let's say we want to just increase the machining level to 8. This gives us a 41-degree engagement angle. Level 3 was like 35. It's okay, we want to change to level 8. Hit OK. We'll calculate our toolpath. So as I said, in 3D iMachining, you're not going to notice any major drastic difference, but there's lots of things we've done, in the operation that has helped. So definitely go through the what's new for 2021. And see all the little things we've done and little features, because pretty much every feature we've added is something that came from a customer request. So it is very possible that it's something we did on our own, but many times it's coming from customers. So let's verify this toolpath. We will click simulate. As we know from iMachining, we always want to cut deep. So as we see here in this cavity, we found the deepest part of the model. It does that deep depth of cut, and now we work upward with the flute. That gives us our largest metal removal rate and adds the best ability to the cutting, because one of the main points of iMachining is being able to cut deep depth of cuts and not shallow depth of cuts, which is tougher on the tool. So here it's gonna, finish machining around the part. We've machined the part. If we want to analyze how the roughing kind of looked in NX, we have our analyze option. In analyze, this basically creates a heat map of material. So, what we can see is that, basically we have 1 to 2 millimeters kind of everywhere, but, in this area here and in the, in these slots, we can see there's a lot of material, because basically the tool couldn't fit. So the tool was too large, couldn't fit in there. So how do we take care of that? Really simple. We just end up using a smaller tool. So we can just copy and paste the operation. As I showed before, creating new operations is really quick. Copying and pasting is also really quick. In this instance, I'm literally just changing the tool. So now we're just going to use a smaller tool. So we went down to an 8mm tool, and we'll just generate the toolpath without changing anything. So basically we've just went from, hey, we had a bigger roughing tool, and now we're going to go to a smaller tool, and we're asking iMachining to find all the areas that it couldn't machine. So while this is calculating, I can maybe talk about a few things in the background with iMachining 3D. So since in the previous version, we've definitely done more things in iMachining 3D for multi-core calculation. So now if you, depending upon the size of the part and how many pockets it finds, the multi-core, we've really been able to speed up the calculation a large amount. This is kind of a smaller size part, at least in, in comparison to the size of the tool. So definitely this has gotten a little faster, but I don't think on a part like this, maybe you'll notice such a big difference. But, we've had customers who have come to us with pretty large parts, lots of pockets and things like that, aerospace style, like, aerospace style airframe parts with lots of pockets and big pieces. So the multi-core stuff has gotten, we've spent more time to make things faster. Let's see, what are some of the other things we've done in the background of iMachining 3D? The adaptive engagement angle for the step up, I think, was a pretty big thing that we did. Because in the past, we, if at the shallow depth of cut, you were, the deepest depth of cut, you were cutting with like a 30-degree engagement angle. We basically kept 30 degrees through the entire tool path. So your step over was the same the entire tool path. But as we know from the iMachining Wizard, if every depth of cut that you pick in iMachining 2D, you get a new engagement angle. So, if you're cutting 1.5 inches deep and then you cut to a 1/2 inch deep, you get a new engagement angle. So in iMachining 3D, the request was, hey, we do this through the wizard when we're doing 2D iMachining. Can we get that dynamically through 3D iMachining? And this is something we did do. That is actually something that definitely decreases the cycle time. So let's go to verify. So that's a nice feature. It's something you kind of get for free. It's the default option now, but you can remove it. So here with the smaller tool, now it's going to go in and clean out all the areas that didn't cut before. I mean, as you noticed, the toolpath calculation was longer for this operation than it was for the first one, because in the first one we had just a very simple stock. It was the rectangular stock. As you progress through the operations, your stock is going to get more complex, and iMachining 3D is using the true IPW, the in-process stock or in-process workpiece. So here we can see it's really going along, and really the awesome thing about iMachining 3D is how it brings that model into that net finish that's ready for either semi-finishing or finishing. So I mean, we come in here, we can really see the difference between the first tool and the second tool. You really see how the stock takes shape to the contour of the part. And if we go to our analyze, now we can just analyze. Obviously, we're going to see that all these areas look better now because this tool actually went in there and machined out that area. But it's always awesome to use the tools of the simulation and confirm this. So yeah, see, everything looks pretty good. Obviously, down in this little section here, I think you actually need like a ball mill to finish that to squeeze in there. So even this tool couldn't squeeze all the way into the floor, the sharp corner tool. And yeah, so that's iMachining 3D. As I said, you're not going to notice a tremendous amount of things in the UI changing, but if you look at the what's new, definitely a lot of little things that you may see that we've done, and you can take a look and see if they're a benefit to you. Let's jump back to this presentation. A huge, as funny as it seems, a huge thing we did for this new version that we learned from the past several years of working in NX is installations, and we've created a new installer. So what does this new installer have? The most important thing, well, not the most important thing, it's an MSI installer. That's just new technology from Microsoft. It's a new installer. The big things are this single install supports all of the NX versions and all of the supported languages. So for anybody who knew before, you had to go and download the iMachining for NX version that was set up for the NX version that you had. Now this supports all of the versions of NX. I think as everybody knows now, NX has now moved to their continuous release schedule. So you basically get a new NX version every 6 months. What this means is really this is a lot of, I'm not gonna say a lot of updating for us, but it's something that we needed to manage more simply. So now we have a new installer and it manages all these different NX versions. It also supports multiple NX versions on the same computer. I don't know if anybody actually needs to do that, but this is now technically possible, where in the past it wasn't. And we have this connector tool, which is a whole new tool to manage how the integration of iMachining for NX connects to NX. And one of the things we learned through the years is that Siemens NX is so powerful with its customization that can be done at the customer level. So what this, in a traditional sense, SolidWorks and stuff, it kind of, the install and configuration of all this stuff is, I'm not going to say locked down, but it's not meant to be something that you can really do a lot of modifications to. In NX, the larger the customer, the more wild they can set up the environment of NX. As we've seen through Ford and some of the larger companies, they really have, huge sorts of, PLM style running of NX to really protect and manage from a high level everything that the engineers are doing in NX. Now, what this means is that trying to get SolidCAM's iMachining for NX integrated into NX was tricky. So I mean, if you just have a simple install from a one guy who just installs NX, does it the basic way, the install worked perfect for us. But what happened is, as customers had crazy installs, I mean crazy as in complex, as not, you know, not the standard stuff, you have batch files that are pulling stuff from servers and dynamically doing stuff. So now we have this tool. It basically scans. It's something we worked with the NX developers on and their tech support to really try to make something really, you know, more powerful. So now it does a much better job of scanning the computer for the NX version. Most important, you also have you can explicitly control which directories it's going into, and it's also more easier for us to show how, for larger customers, what modifications their IT group may have to do to their batch files. Because as I said, there are some customers that the IT is running their own batch files to set up the environments dynamically every time for every user, every time they launch NX. So in that instance, they have to add some things to their scripts, so that way the template files for iMachining for NX are installed. So seems silly, but this was honestly, I would say, one of the things we worked the hardest on was this new installer utility, because it's something we really wanted to manage better. And last, to download, you know, where do you find iMachining for NX, the new version? From the website. So I think everybody, you know, every customer should have a login to the iMachining for NX website. So if you need the new version, you can go to the website and you will find it. You will find it up there. And that's the end of my presentation. Let me see if anybody has if anybody came up with any questions. Go to meeting panel. Let me pop this out. Okay, release NX CAM and release iMachining for okay, Andre is asking NX. I think maybe I mentioned this now. So the release version, it's now released. It is on the website, so you can go to iMachining for NX website and get the release. Andre asked to show the settings window. So yeah, I mean, for, you know, not that this is something. I think that panel's probably in the way, so let me slide it down here. So for any of our resellers that are in here, you can now notice you can get now to the full SolidCAM settings. So this is different than before, because this is now the full SolidCAM. This is the full SolidCAM that's integrated. It's not the full SolidCAM in that you have all the rest of the toolpaths in SolidCAM, but it is the full same version of SolidCAM that runs in SolidWorks or that runs in InventorCAM. When it's integrated into NX, of course, the only thing you get is iMachining 2D and iMachining 3D. So, but you do have the full settings window. It would be great if iMachining have an option to cut only in integer ACPs to improve cutting stability. Well, that's an interesting idea, Helder. I'm assuming this is talking about iMachining 3D. Yeah, that's an interesting idea. I mean, for anybody that is cutting with iMachining, as you know, the ACPs really make, you know, depending on the machine and the material and the tool, the ACPs really can do something magical. So being able to cut at the integer ACPs it's the difference between, you know, vibration and beating up the tool and it just being so silent you can barely tell the machine is cutting. So that's an interesting idea about only cutting on the at the ACPs. As I said, in iMachining 3D, we can limit the step up to never go below 1 ACP, because below 1 ACP really beats up the tool. Like, that's like the worst time for the tool. Andre is asking, I think he asked, so why on this part it did the helical entry? and why it didn't start from the outside. And I mean, that's because even though it looks like it's an open pocket, it is basically a cavity. So there is no way to start the cutting in this area from entering from the outside. Now, if you wanted to be able to do, some of the levels with open pockets, if you change the step down to not be a full depth of cut, like full flute length, then, if you broke this up into like 2 or 3 levels, then you would get, some of those levels starting from the outside, and it wouldn't have to be, helical entering. But you're still, once you get down so far, you're going to have to enter with helical entering on this geometry. And iMachining does this automatically. So in the algorithm, we are always trying to enter from the outside, right? So this is like the last thing the toolpath ever wants to do is helical enter. So we do everything we can not to helical enter. And Helder also asked, does the zigzag take into account the extra force and adapt the toolpath in the same way? No, there's with zigzag, it is it is what it is. If you have a machine and you have a material and you can cut in zigzag and it will work, it will work. But I mean, in all my experience, every time I've always done conventional cutting, I got to be honest, I can't think of a single time that I found that conventional cutting was something that I personally would accept. But as I said, if you're doing big machining on a big part and it's aluminum and you think it's acceptable to do zigzag and climb and conventional cutting, then you can do it. I mean, I still, to be entirely honest, I've never seen a video from a customer. This was added because some other softwares had supported it, so it was an option we added. I've not actually heard a customer use it and send a video and be like, wow, this was awesome. I love the zigzag machining. I think it's one of them things that people think that you can do, and it's going to work better than you expect on the machine. But it's there, it's in the software, so it's use at your own risk. And okay, yeah, I think that's it. So I appreciate everybody for joining the video. Joining the presentation. I hope it was fun and informative. We are really excited about this new version of iMachining for NX. The fact that it's on the same code base and it's with the same release schedule as our InventorCAM and SolidCAM products, man, it really makes a huge difference to us in support and to the end user, because now we're giving the same code and the same software to all the customers equally, and this is really what we want. So we're really happy about it. The new installer utility is really powerful, even though it just looks like it's a simple dialogue. You couldn't believe the amount of work we put into the installer utility and to have all the versions and languages and everything all wrapped up into that. So great. Well, thank everybody again. And if anybody has any questions, please reach out to your reseller. Or if any of the technical staff from SolidCAM is in here, you can always reach out to myself or Chris Calderone, the iMachining product manager, if you have any questions. Thanks. Have a good day.